Okay, hello, good evening, guys. Looks like we have a new friend here. Uh, Daravins, is this how I pronounce your name? Okay,
Yes,
is there a shorter way I can pronounce your name?
Darwin.
Okay, oh, just Darwin.
Yeah.
Okay, sure. Right, so yeah, where were we, guys? Okay, looks like others are late. Okay, so where are we, huh? We are currently revising on our chemistry, which is our chapter 7. Okay, so Darwin, I don't know where you are currently in your school. Have you finished your syllabus of your year 8 syllabus? Have you?
Huh?
Have you finished your year 8 syllabus?
Not yet.
Oh, not yet. Not yet. Okay.
Yeah.
So we are doing our chemistry revision, by the way, huh? So because we are following my syllabus, okay, my speed. So see if you can pick up for anything here. Tomorrow diet assessment. Why? What's up? What's up, Jaden? Is the assessment going to be hard? I thought you say you have no you still have you don't know when's your exam. Is that gonna be your final exam, Jaden? Is it? You don't know Oh, so it's like a impromptu thing lah. Wow, they can do it this way? That means they can just okay. Wow, damn, they do that? Why is your school like that? So they find joy in scaring y'all. What the hell? Okay, anyway, so let's go to our question 2. I think we stopped around here. Okay, we did so Darren, we did this last week. What is your solid, your liquid, and your gas? Okay, how do we draw them? Solid, they are arranged very closely. The atoms are very close. Liquid, they are a bit further so that they can easily slide. Gas, they are very far so that they can, travel very randomly. Okay, so Jaden, see if you can pick up anything lah. I mean, chemistry stuff. I'm revising currently. Biology, I think you already learned it. We gone through it twice already. Biology should be no problem to you. And year 8 stuff, the most difficult, I would say it's gonna be your year 8. Okay, it's gonna be a biology. Okay, so go and revise your biology if you can. Okay, so go and read back my notes. So I think we stopped around here. So what your charcoal is a solid, steam is a gas, hydrogen is also a gas. Excuse me. And then ice is your solid, petrol is a liquid, kerosene is also a liquid. Okay, guys, what is kerosene? Kerosene is the same as petrol. They belong to the same family. They are your fuel. Okay, they are just, something you burn to get energy, just like your petrol. So sulfur is a solid, mercury is a liquid. Okay, so I'm just gonna keep everything short, I'm just gonna keep everything short. Okay, so Darwin, if you have any question, please let me know, because we have done the syllabus already. Okay, so number 2, matter has mass and occupies space. It consists of small particles. So this is an example of matter. So this is a cup of coffee here. State the matter of P and Q. P is the coffee. Okay, so coffee is a solid. It's a liquid. Okay, P is a liquid. Right, and then Q is the cup. The cup is a solid. This should be very easy. Okay, liquid and solid. And then B, a spoon of coffee powder was poured into a cup of water. After 15 seconds, the water changed into black. How does the water turn black? Okay, so we learned this as well. When things they turn black, okay, when you dissolve something in water, okay, let's say you take a bit of salt, you throw it in water, you stir it, the salt will be gone. This is what we call diffusion. Okay, we learned it last week. What is diffusion? Diffusion is the spreading of things in a substance. Like when your mom sprays perfume, okay, when your mom sprays, okay, when your mom cooks, okay, as long as you're in the house, few seconds later, you can smell what your mom is cooking. That is what we call diffusion. So same thing here. Same thing is the spreading. So your mom cooks is spreading in air, okay, in gas, but this spreading is spreading in liquid. So how does it turn black? So you can say the coffee particles, okay, coffee particles diffuse, okay, diffuse in water. So this is called diffusion, the spreading of this coffee in water. So what do? They get into the space between atoms. Right, let me repeat this. Let me repeat this. When something dissolves in another thing, they spread out. Okay, I don't have a very good diagram here because this is a short note. Okay, so let's say this is air. Okay, this is air, right? When your mom cooks, when your mom cooks, let's say your mom cooks curry. Okay, let's say curry particles like this. So when a curry particle they spread out, they get into the space between these particles, right? So this is what we call diffusion. So in this case, the coffee particles, they move into the space between water particles. If you get what I'm trying to say. Okay, so they move into spaces between water molecules. Molecule is particles, same thing. So in between water, there are spaces, right? So when your coffee moves into between the water molecules, so you will get a cup of coffee. Okay, this is why when you stir them, they will go into the space faster. So this is your diffusion. Okay, we learned this like 2 times already. This is the second time. Okay, so C diagram 1.2 shows the particle of one of the state of matter. Obviously, when you see things are arranged so nicely, this is for sure solid. Okay, for sure this is a solid. So describe the arrangement and movement. Okay, how are they arranged? How do they move? How are they arranged? They are arranged very uniformly. Okay, they are arranged very orderly. Right, they are arranged orderly or in an orderly manner. They are arranged very closely, very tightly. So how do they move? Can solid particles move? They cannot move. They only vibrate at their fixed position. This is why they are solid. This is why, okay, let's say this remote control is a solid, right? This thing doesn't flow. This thing is hard because the particles, okay, the atoms, they cannot move. They are hold together in a fixed place. Okay, so they vibrate at fixed position. Okay, they only vibrate. Liquid, they will flow, they will move freely. Okay, liquid, they can flow. Gas, they move randomly. That means they will run everywhere. Gas is very excited, so they run. All right. So number 3, diagram 4 shows Jihan frying some chicken in a wok. Okay, so you can see here, this is the that's P and Q. Okay, so he's frying chicken. So what is P and Q? P is a gas. When you cook oil, right? Oil will also evaporate, you see? Oil will also evaporate. Not just water. When you cook a pot of water, you see steam coming out, right? This is your oil vapor. This is your oil vapor. This is why, right, if you cook in a house, you have to take this oil vapor somewhere by switching on your exhaust fan. You have an exhaust fan in your kitchen, right? Right? You have a fan up your, maybe in your kitchen, there's a fan that, draws this thing out so that this thing doesn't stay in your house because your house will smell like oil. Okay, which is not nice. So that's your P piece of gas. So Q is the wok. This wok is a solid. Okay, this wok is a solid. Okay, this wok is a solid, and of course, the oil inside is liquid, They didn't ask for it, just to let you know. So B, draw the arrangement of P and Q. So how are they arranged? P is a gas, so they are arranged very loose. Okay, very far away. Solid Q, they are arranged very tightly, very orderly. They look like this. Okay, try to draw this big, like I said, don't be cute and try and draw like this, you are gonna waste your time. Okay, draw it big, so you save time. I just draw like, how many here? 12 here. Save your work. So solid, they are very nicely arranged, very, very uniform, very in order. So C, relate the compressibility of P with this arrangement of particles. Okay, what is compressibility? That means, can you compress them? Okay, can you compress them? Let's say this is a bus. Can I ask all the atoms to go in some more? Yes, I can, because there's a lot of space, right? There's a lot of space here, right? So I can press them smaller. So can you compress P? So we can say P is compressible. Okay, because the particles are loosely arranged. Okay, or you can say they are far away from each other. They are loosely arranged. So there are a lot of space in between them. So can you compress solid? You cannot compress solid. Solid, they are already full. You cannot press them smaller. Air, you can. Air is very easily compressed. Okay, this is why your mosquito repellent, your shield tox, whatever, you have mosquito at home, you spray with that thing, right? Inside is compressed air. Okay, so next D, relate the shape and volume of Q with this arrangement of particles. Okay, so since how are they arranged? They're arranged very orderly, right? Q is arranged orderly. They are like soldier, nicely queued up. So can they change their shape? No, they can't. Can they change their volume? No, as well. Now the shape here is fixed. The volume is fixed. If this is 10 cm cube, 10 ml, this is forever 10 ml. Okay, so it is arranged orderly. It has fixed shape and volume. Okay, solid cannot change anything. They are solid for a reason. You cannot change their shape, their volume, whatever. Okay, very simple. I know this is very boring chapter, guys, because it is. It's very easy and boring stuff. So you choose easy and boring, easy but boring, or hard but interesting. It goes like that, right? So like your biology parts, when you learn human body parts, yeah, it's very interesting, but it's very, very hard in exam. So this one, very boring, but very easy. So next, number 4. The following diagram shows an activity carried out to study the diffusion of particle in a gas. So you see, they diffuse in a gas. So this is air here. So you have air particles here. I'm just going to draw it out. Air particles here. So when they put bromine in, what is bromine? Bromine is this brown color gas. So this brown color gas, what they will do? They will start to move in between the particles. They will diffuse in. So at the beginning, you only see brown color here, and then as time goes on, this brown color will spread out, and then this whole thing will turn brown. Right? This whole thing will turn brown. This is diffusion. Like I said, diffusion is the spreading. Okay, at the beginning, there's no brown, and then brown starts to spread. The spreading is called diffusion. Okay, spreading of your mom's cooking in the air. So that you smell her cooking after a few seconds. So spreading is the diffusion. So A, based on the diagram above, explain why the tube turns brown after a few minutes. So why does it turn brown? Okay, because your let me change my pen. Okay, because your bromine particles, what do they do? Diffuse. Bromine particles diffuse in air. Okay, so again, same answer like just now. They move in between spaces of air particles. So you see, between air particles, there's a space here, right? So they move in between the space. So that's how they spread out. That is how they spread out. You see, diffusion, you write back the same thing. Okay, it's the same answer and explanation over and over again. Okay, so next. So this is your bromine gas particle. You see, gas, they just move randomly. Okay, they just run here and there. So B, explain the movement of the bromine gas particle. So how do they move? How do they move? This is your gas ready. So gas, they move randomly. Okay, gas, they move randomly and they move in all direction. Okay, randomly, all direction. They have no followed pathway. They just move wherever they want in all direction. Okay, so what's the definition of diffusion? Like I said, it's the spreading. Okay, the spreading of particles of a substance. Okay, let's say gas, let's say liquid, let's say gas, okay, let's say solid. Spreading of particles of a substance in another. Spreading, you see, spreading bromine in air, spreading one substance in another. So that's your diffusion. Okay, so which June today? He's not here. Okay, I think two were missing today. Okay. Anyway, moving on. Let's go to D. So this is diffusion also. So a creative science activity is carried out to investigate the diffusion in solid. Some food colorings are dropped into a container that contains gelatin as shown. So what is gelatin? Gelatin is this jelly-looking thing. I don't know whether you've seen this before. Gelatin. We use this to make kueh. You know this? You know this? So there's a gelatin. So when you put color in it, they will start spreading. This is how you dye your jelly lah. Okay, because jelly originally, jelly or jello lah, they originally look like this. So you give them whatever color, they will just follow whatever color you want. I mean, I don't know lah, guys. This looks disgusting to me. I wouldn't want my food to be rainbow. Right, so this is what they are doing also lah. So they put food coloring here, and then after a while, right, this food coloring will start spreading. It will start spreading everywhere. Okay, so explain why there are various colors spread in the gelatin after a while. So why do they spread? Because gelatin they diffuse. Same answer again lah, because gelatin diffuse in. Oh wait, not the gelatin, the food coloring. Sorry. Okay, brain fart. Okay, so your food coloring. Okay, food coloring diffuse in the gelatin. Okay, so the food coloring diffuse out. So what's the explanation again? The particles move into between the spaces of food of your gelatin. Same answer again. Okay, so your particles of food coloring it move into spaces between gelatin particles. Oh my God, so easy, okay? It's the same answer over and over and over again. I repeat this thing until nausea already. Okay, you get the point. Okay, so number 2, if you put the container in the refrigerator and another identical at room temperature, does the food coloring diffuse at the same rate? Explain your answer. Right, diffusion depends on temperature. Okay, the hotter something is, the faster they diffuse. Okay, think about this. Hot food, they smell nice, right? You go to restaurant, freshly prepared food, freshly cooked food, they smell nice because they are hot. So they diffuse quickly in air, so you can smell the food. Do you smell sushi? You walk into a sushi restaurant, do you say, nice sushi? No, because sushi is cold. Sushi is cold. Sashimi is cold. You don't smell sashimi unless you eat it lah. Different story lah. So you don't smell it because it's cold, so they don't diffuse. So you don't really smell anything. All right. So to be fair, if you spray perfume in a cold aircon room, you don't really smell anything. I mean, you do, but very slowly. But if you spray in a warm room, very quickly you will smell. Okay, so you get what I mean? All right. So one they do 2 of this container. One they put it in the fridge. One they put it in room temperature. So are they the same rate? Of course, no. Okay, no. So the room temperature one is faster than the fridge one. Okay, you understand what is this sign, right? It means faster than. Okay, more than. So the room temperature one is faster than the refrigerator. Why? Because the higher the temperature, okay, the higher the temperature, the faster the diffusion. Okay, hotter, faster. Hotter, faster. Hotter, they spread faster. It's like you drop, okay, let's say you have a cup of water, right? Let's say this water, you take a blue color dye, you drop in it. Cold water, they spread very slowly. But hot water, you drop down, while they start spreading very quickly. So it's the same concept. It's the same concept. This is why you use hot water to make Milo, right? I mean, you can use cold water, but the diffusion is not going to work, and you will end up with lumps. Okay, end up with very disgusting looking Milo. How do I know? Because I've tried it before. Yeah, I've tried it before. Okay, I didn't get enough sleep, so I didn't boil the water. I just pour cold water into my Milo powder, and it starts stirring. I was like, what the hell is wrong with today's Milo powder? Why is it so hard to dissolve? There, okay, you use cold water, you will know. Okay, so I end up throwing the whole thing because I cannot drink that anymore because it's full of, it's lumpy. So you get what I mean lah. The hotter something is, the hotter it is, the higher the diffusion, the faster the diffusion. Okay, so next, number 5. Okay, number 5. So this is the same question, almost the same thing. So the diagram below shows the balloon in a birthday party. The balloons were filled with perfume before they were tied close. Wow, that means all these perfume is all these balloon inside has perfume. Okay, so guests who attended the party could smell the fragrance. Why diffusion again? You see, balloons, right? When you zoom into a balloon, okay, this is a balloon, right? When you zoom into a balloon, you actually see tiny holes, very tiny holes. This is why your balloon, okay, if you get a fresh balloon, freshly blown balloon, after a few days, right, the thing just kind of looks lame because now originally your balloon was very big. Now the thing just shrinks and kind of looks lame. Why? Because diffusion also. Because these holes, right, some air they will manage to escape. They will. Okay, they will manage to escape, and before I know it, this thing will lose air. Okay, they will just shrink. Same thing. This is what they're trying to do. They put perfume inside instead. So this perfume will spread out. And now they smell whole perfume in the room. Damn, I can only imagine this room is gonna smell terrible. It's gonna be full of perfume, right? I mean, a little bit is fine lah, but wow, that much of balloon, your room is gonna smell like crap. Right, as in it's gonna be really terrible smell. So how did the fragrance get from inside to outside the balloon? So how do they do it? Okay, they spread out lah. So it spreads from inside to outside. Why? Because diffusion always happen, they always go from high concentration place to low concentration place. You get what I mean? You get what I mean? Okay, that means you go from a crowded place to a less crowded place. Same thing. When your mom cooks, right? The kitchen is full of that garlic smell. Let's say garlic lah. Okay, the kitchen is full of garlic smell. It's crowded with garlic particles. So they will want to run. They want to run to the living room. They want to run to your room. So they run to your room. They spread out. Okay, they go from crowded place to less crowded place. That's why you can smell the garlic or whatever that your mom is cooking. Right? So what is this process? This process is called diffusion. Okay, this process is called diffusion, as I said just now. So B, when a balloon filled with air was left for a day, it became smaller. What can you infer from this explanation? Infer means you explain. So why? Why do they become smaller? Like I said, because the air diffuses out. Okay, air diffuses out of the balloon. Okay, so it diffuses out. Right, so guys, we skip C. Okay, we skip C because there's some problem with this question. We skip C. So air diffuses out of the balloon, so that's why your balloon becomes smaller. It will happen. Okay, no matter how good your balloon is, they will become smaller. Right, so let's skip C and let's go to number 6. This is diffusion in water. So what are they doing? So they drop this red color liquid into 3 different cups of water. Okay, one is carbonated drink, soft drink, one is mineral water, one is fresh milk. So you see, fresh milk is slow. Okay, fresh milk is slow, and then mineral water is the fastest. Carbonated drink is fast. Why? Because mineral water is the most empty. You see, mineral water is almost empty water, but fresh milk, it has a lot of things inside. Okay, it is very crowded inside already. So to spread out in fresh milk is gonna be very slow, right? It's just like running through a crowded place. It's gonna be hard. Running through an empty place is easy. So same thing lah. So mineral water is very empty, so it's very fast. Fresh milk is very full, so that's why it's slow. So A, predict what will happen if jelly is used to replace mineral water. So jelly is even cooler because jelly is a solid. Okay, jelly is a solid. So if I replace mineral water, so you can say the rate will decrease or will be slow. Okay, so one factor that affects the rate of change of liquid color, you can say the state of your liquid state of matter, instead of matter, whether they are solid, liquid, or gas. And then C, Mrs. Jaslina is cooking meat soup in the kitchen. Her daughter in the living room can smell the meat soup. Exactly the same answer. Okay, so you say diffusion. Okay, you explain yourself lah. The meat particle diffuse in air from kitchen to living room, move in between space of particles, the whole thing. Okay, it's the same explanation over and over again. Okay, get it, easy, So next, number 7. Guys, this is even easier. Please do not get this wrong in exam. Oh my god. So what is P? To change from ice to water, P is called melting. So Jaden, you pray hard your exam, ask this a lot, then you'll get free marks here. But I doubt so lah. This is just too easy. I don't think they will ask a lot of this. So what is R? What is Q? Let's explain Q first. From gas to liquid. If you wear glasses, you will get what I mean. Okay, you eat noodle, there will be fog on your expect, right? This is called condensation. Okay, condensation. This happens when you have a cup of cold water. So outside your cup will be full of, the water vapor, right? The water droplet, because in air there's water. So they touch your cup, it's cold, so they turn to liquid. So what is R? What skips liquid? What goes straight from solid to gas? This is your dry ice. Okay, dry ice. Dry ice is your frozen carbon dioxide. They will straight away change from solid to gas. So this process is called sublimation. Okay, sublimation. Okay, next B, underline the correct answer. Process P involves, okay, so what is P? Easy, does it absorb heat or does it release heat? Okay, this one you just look at the temperature. Ice is cold, 0 degrees cold. Water, the water you drink is 30 degrees. Okay, so they become hot, right? They become hot, right? The ice become hotter. So how do they become hot? They absorb heat. Okay, they become hot by absorbing heat. Okay, they absorb heat. So next, number 2, the rate of movement of nitrogen dioxide particles in the air is dioxide is gas. Movement of water in a cup. Water is liquid. So who moves faster? Gas or liquid? Of course, gas, right? Gas, they just run around. So gas is faster than water. Number 3, you don't care, but I can tell you the sun is a plasma. Okay, the sun is not a solid, the sun is not a liquid, the sun is also not a gas. Okay, because the sun is a plasma. You might say, what the hell is a plasma? Plasma is like your fire. Fire is not solid, fire is not liquid, fire is also not gas, fire is a plasma. Okay, yeah, that's the 4th state of matter. This is not your syllabus, you don't need to know, I'm just telling you, okay, for fun. Right, C, explain the change in the vibration of particles during process P and R. You see what happens in P and R? P, they become hotter, R, they also become hotter. So to become hotter, what happens? The particles, they vibrate faster, they move faster. As I gain heat, I move faster, and I move so fast that I melt. All right, because you see, when I go from solid, let's just say this is liquid, I go from solid to liquid. Can I see I move further apart? I move faster. Okay, I hope you understand. Hope you understand. So your answer would be they vibrate and move faster. Okay, so they are now further away from each other. They become further, further away. So D state the natural phenomena that involves P and Q. So where can you see this naturally? Where can you see this naturally? Where do you see P? Where do you see melting in nature? So many things. You can say the melting of snow. Okay, snow when they melt, when it's springtime, snow when they melt, that's your P, melting. And then Q, from gas to liquid. This is your, I can think of one, formation of rain. This is how your rain comes, right? Okay, when gas, they condense and they become liquid, so you have your rain. Okay, so guys, when there's more evaporation, there's more cloud. When there's more cloud, there's more rain, just like us, Malaysia. Okay, Malaysia here, we rain a lot because there's a lot of sun. Okay, so when there's a lot of sun, there's a lot of evaporation, there will be a lot of clouds, and there will be a lot of rain. Right, so all rainforests are like that. All, tropical countries, you go to Brazil, okay, you go Brazil, you see the same thing. and you go like Colombia, you go Mexico, you will see the same thing. Okay, because you have sun, you have evaporation, you have condensation, then you have rain. Okay. Sorry, guys, my spec is very foggy here. Okay, right, let's move on. So E, water can change from one state to another with the change of temperature. Complete the following table to show the heat that changed. Right, so solid to liquid, does it absorb or release heat again? Solid is ice. Okay, ice is like 0. Liquid is 30. The water you drink is 30, so they become hotter. When they become hotter, they absorb heat. Okay, so this process is called melting. Same as up there. Next, liquid to solid. When I go from 30 back down to 0, this releases heat. Okay, they release heat. So this is called freezing. Freezing, when you freeze your ice in your fridge. And then gas to liquid, gas is very hot. Gas is 100. Liquid is 30. So they cool down, so they release heat again. And release heat. So this process is called condensation. Oh, same as up there. Same as up there. Right, next, F. Name the process that are involved in a change of state in daily life. So number 1, a student's glass fog up when he eats hot mee soto on a hot, cold day. If you wear glasses, you know what I mean lah. Hey, Jaden, do you wear glasses? If you wear glasses, you know what I mean. This is the most annoying thing that happens to you. When you wear glasses, you eat noodle, you get fog on your specs. This is condensation. Even sometimes when you stay in an aircon room for very long, and then you go out, you get foggy specs as well. Okay, happens. So number 2, a chocolate melts after taken out from the fridge on a hot day. You see melt. So melting lah. Okay, easy. And then number 3, mother finds that her volume of soup decreased after 1 hour of cooking. So she keeps boiling the soup. Oh, I said the answer already, isn't it? Okay, she keeps boiling the soup. The process is called boiling. Boiling, okay, when you boil, water will change to steam. And then number 4, wet clothes that are exposed to the sun dry after 2 hours. So you dry your clothes under the sun. That is your evaporation. This is what your mom does every day. If you don't have a dryer. Okay, guys, do you have a dryer at home? Do you have a dryer at home? Okay, if you don't, lately it's been raining every day, isn't it? Okay, lately it's been raining every day. So if you don't have a dryer, what a dryer looks like, by the way. Your dryer machine looks like this. Do you have this at home? Do you have this at home? If you do, then you don't need to hang clothes already. So your clothes is going to dry faster, and you don't get that weird smell from your shirt you get when you don't dry your clothes properly. Okay, so it's worth to have one. Okay, anyway, this is your dryer. Next, number 8, this is the melting point and the boiling point of a fused substance. So what is meant by melting point? What is a melting point? So your melting point is the temperature where a solid melts, right?